So here we are going to demonstrate about solar tracking system and water pump, automatic water pumping system by using ARM7 board. So here you can see ARM7 board which is used to read the data from the LDR sensor. So there are two LDR sensor, LDR1 and LDR2, which is going to give input instruction to the LPC2148 controller. So here you can see the LPC2148 controller, so which will be working on 5 volts DC, and the crystal oscillator frequency is around 60 Hz, 60 megahertz. So the input voltage which we are going to give is an 12 volts 1 amp lead acid battery, which will be giving input power supply to the regulated power supply section, which is present in the ARM7 board. So in this regulated power supply section, here you have bridge rectifier, 1000 microfarads capacitor, 7805 voltage regulator IC, LM1117 voltage regulator IC, where 3.3 volts is given to the controller IC, and 5 volts to the LCD display, moisture sensor, L293D driver IC, which is used to rotate the motor, where the motor power supply is given via battery to the L293D driver. Why? Because the motor will be working on 12 volts. So and whereas the pump, here we have used an DC water pump, which is also working on 12 volts DC. So this is being used to pump the water at the fields. So when the moisture sensor is at the dry state, so it is the pump is going to turn on, means the relay gets turned on. So where the battery power supply is going to give input to the DC water pump, where the motor RPM is around 18,000 rotations per minute, and here you can see the Pelton blade which is present over here. So according to the water level, it is going to suck the water and pump it out through the small nozzle which is present over here. So here before that, coming to the solar panel, so there are different type of solar cells. So like monocrystal, polycrystal, crystal solar panel, high concentric solar panel, concentric solar panel. So there are different type of solar cells. So here we are going to use an crystal solar panel, which is going to give input power supply to the battery. So that is not given directly to the battery. Here we are going to use a charge controller, where it consists of an maximum power point tracking, and at the same time there is an LCD display to show the voltage values which is coming from the battery and the solar panel. So the data which is coming from the voltage coming from the panel is being given as an input to the charge controller, where the output is being boosted and given as a constant output to the battery, so that the battery gets charged. So this is how the power supply is being distributed in between all the electronic components which is generated by the solar panel. So according to the input voltage reading, so the L293D is going to give an input instruction to the motor. So coming to the motor, this will be rotating at 2400 RPM, where the 3.5 gearbox is used to rotate the panel. So the panel is withstanded on the nut and bolts connected to the clamps, and this is how it is going to rotate the motor clockwise and anti-clockwise direction according to the sensor input value, depending on the light intensity falling on the component. So this is how the project is being demonstrated.